This is A level, year 14, and it's A22, which is Physics 5, and this is the first unit, capacitors. So these are the answers to some of the worksheets I gave you. And this was a worksheet, I'm just going to call it worksheet 3, called capacitors. You got that quite recently. So these are just old past papers, a few old past papers. So question 1, figure 1.1 shows a circuit to enable the capacitance of a capacitor to be determined by measuring the time constant tau. So you can see you've got a voltmeter, a capacitor and a resistor in the circuit. The resistance of resistor R is 47 kilo ohms. With the switch S1 closed, the voltmeter reads 18.2 volts. S1 is then opened, and after 45 seconds the reading on the voltmeter drops to 6.7. So it's initially charged to 18.2 volts, but once the circuit is opened again, then it starts to discharge through the resistor. Show the time constant of the circuit is 45 seconds. So you're told after 45 seconds the voltmeters dropped to 6.7 volts. So if that is true, if the time constant of the circuit is 45 seconds, then 6.7 should be about 37% of 18.2. We know after a time constant's worth of time that the voltage should have dropped to 37%. So we're just going to check what 37% of 18.2 would be, and so the voltage after that length of time should be 37% of 18.2, and when you do that it comes out as 6.7 volts as we would hope. So that's just proving. There's only worth 1 mark, and that's all that you're proving. Next bit of the question, calculate the capacitance of the capacitor. So in the question you were told the resistance was 47 kilo ohms. You know the time constant tau now from the question above is 45 seconds. And you know the equation tau is equal to C times R. So therefore C is equal to tau over R. So C is equal to 45 over 47 kilo ohms, which is 47 by 10 to the 3. And that comes out to be 957 microfarads. Right, the second page then. The 470 microfarad capacitor is first charged, the 470 microfarad capacitor in this question is first charged by closing the switch S1, which connects it to a 12 volt supply. So you can see it's charged in this circuit. Then switch 2 is initially open. So the first bit of the question we're really only dealing with, if I just draw this on its side here, we know that's 12 volts, and we know that this is 470 microfarads. So really it's that part of the circuit turned around, and that's it there. What is a charge? So Q is equal to C times V. C is 470 microfarads and V is 12 volts, and that comes out as 4640 microcoulombs, or 4.64 millicoulombs, or by 10 to the minus 3. The next part of the question, calculate the energy stored in the 470 microfarad capacitor. So if you just use one of your equations, we now have charge, we have capacitance, we have voltage, so it's up to you what you use. I'm just going to use A is equal to half QB, and that's a half times Q is 5640 by 10 to the minus 6, and V is 12. And that comes out as 33.84 by 10 to the minus 3. And you have to write it in millijoules, just be careful of that kind of thing. So it's 33.8. Third page. S1 is now opened, disconnecting the 470 microfarad from the supply. S2 is then closed, connecting the charged 470 microfarad capacitor to a non-charged 220. So really what we have here now is your 470, which had initial charge of 5.64 millicoulombs, and it's now going to share some of its charge with this uncharged 220. And also its voltage is going to change, and it's going to settle so that the same voltage is across both of these now. So this is a very standard kind of question here. What you have is you'll have a total charge, which is this initial charge from over the page, and the total charge initially was a charge in the 470 microfarad capacitor, which was 5.64 millicoulombs. We now know the total capacitance. These two capacitors are definitely in parallel with each other, so you just add them. And so it's 470 plus 220, which gives you an answer of 690 microfarads. And so to find the total voltage, all you have to do is to divide Q by C. And so Q is equal to 5.64 by 10 to the minus 3. And that's divided by 690 by 10 to the minus 6. And that answer comes out as 8.17 volts. Now you know it was initially charged to a 12 volt battery, so that's right that it should go down like that, 8.17 volts. The next part of the question asks you to calculate the total energy stored in the two capacitors. I'm just scanning a wee bit there. So A is equal to, and you can use whatever equation you want. I'm going to use A is equal to a half CV squared. And so A is equal to a half times the total capacitance is 690 microfarads. And the total voltage is 8.17. And that gives you an answer of 0.023. And again, your answer, they want it in millijoules, so that's 23 millijoules there. Okay. And the last